Greetings, students. Today we're going to discuss practice quiz number 4 for college prep. Let's begin. Question 1. Find p of 8. So we're going to substitute 8 in for x onto the function. And it's going to become p of 8 is equal to 8 plus 2. P of 8 is equal to 10. This 8 is an x value. Goes in for x. P of x is like y. It's the output of the function. Question 2. It says find the function's value at negative 3. G of negative 3. So we're going to substitute negative 3 in for t here. G of negative 3. Remember, absolute value makes a negative positive. It's the distance the number is from 0. So g of negative 3. G is the absolute value of negative 3, which is positive 3. The proper way to write it would be like this. But again, it's multiple choice, so you're just picking the right answer. All right, next one. W of A is equal to 4a plus 5. Find W of negative 2a. So negative 2a replaces a. Remember, it goes in as a quantity. So when we do this, we're doing 4 times the quantity, negative 2a, plus 5. So 4 times negative 2a is negative 8a plus 5. That's what W of negative 2a is equal to, or the function's value at negative 2a. Negative 8a plus 5b. All right, next one, find all roots. We're asking you here to either factor or use the quadratic formula. So you can attempt to factor this. It may or may not factor. If it does not factor, you will have to use a quadratic formula. So I will show the factoring way. Negative 3 is the value of, excuse me, negative 10 is the value of b. Negative 3c, and negative 3 is the value of b. So a is 1 here. I don't have to worry about a. So I have negative 10, negative 3. So I have negative 5 and positive 2 to make the negative 3 when they subtract. So I have x minus 5 and x plus 2 as my factors equal to 0. Setting each one equal to 0 separately. We get x is equal to 5 as one of my solutions. And as the other one, we get x equals negative 2. Now, if you want to, you can use the quadratic formula here as well, and that will be functional to solve this. You can also complete the square. So for the quadratic formula way, you would do x is equal to opposite of b, 3, plus or minus the square root, b squared, which would be 9, minus 4 times a times c, so 4 times 1 times negative 10, all over 2 times 1. So I'd have that. So I'll just a little bit for you. There you go. I'd have that. And then I'd evaluate underneath this root. So this would be 3 plus or minus the square root of 49 divided by 2. All right, so 3 plus 7, 10 divided by 2 is 5. And then 3 minus 7, negative 4 divided by 2, negative 2. Again, it'll work both ways. All right, so for my class on the next 2 questions, we're not going to have you sketch the graph. The graph is going to be sketched for you. What I want you to do is to approximate the real zeros to the nearest tenth and the relative maximum and minimum. So I will have this graphed for you on the test. You won't have to do it yourself. So I'll graph it here for the rest of the classes. So what you should have for a graph, the rest of you guys when you graph it, is you should have it comes through at 0, 0. And it goes up just a little bit from there. And comes straight back down at 1. Right, like that. And then it comes up from here. Just going straight up from here. Doesn't come down at all. All right, so this is the minimum. Right, here's the minimum. The relative minimum, sorry, not the absolute minimum. That's at 0, 0. The maximum is here, the relative max. Again, relative meaning that it's relative for the area it's in. Now, if you have the graphing calculator, you'll be able to approximate it a lot better. You'll be able to get the actual values. It's about at a half comma 1/10. It's actually 0.7 comma 0.1. For my class, I would take anything, half, 1/10, half, 2/10, anything like that. And then the other thing is the zeros. So there's two zeros here. The zeros are the x values where it crosses the x-axis. So that's also the min here. And then this part, this number right here, x equals 0 and x equals 1. Now you can write them like that, x equals 0, x equals 1. Or, if you prefer, you can write them as coordinates as well. All right, the next one, it comes down to 4. From the top of the grid, like so. So this here is going to be a min, a relative minimum at 0, 4. From there, it comes up, and it has the top of a curve, about right here. So that's going to be a relative max, which is about 1.5 comma 5.5. For my class, that's what I take. For you guys that are doing it on the calculator, it should be 1.3 comma 5.2. 5 and 2/10, 1 3/10, 5 and 2/10. Then it comes down, and it crosses through like so. Right there is going to be another 0, or it's going to be a 0. So it has only one 0 here, about 2.5. And it's actually 2.6 when you work it out exactly. X equals 2.6 on the calculator. And again, for my class, what I'll take here is the approximates. And I'm going to have them graphed for my class for you. So they'll be graphed, and you're just going to have to label min, max, and then zeros. And then give me the approximate values. In fact, if you just put the arrow pointing to the min, the max, and the zeros, that would be fine for my class. We'll talk about it in class on this. We'll go over the test on practice test on Wednesday. But if you just put the arrows pointing out what's what, min, max, and then zeros, I'll give you points for this. All right, next one. Determine whether or not the following relations are functions. So to determine if something's a function or not, you can either do the vertical line test, or you can check to see that each output has only one, or each input has only one output. So what you're looking for is repeating x values on if you have a list of coordinates. So do we have repeat x values? Because if the x's repeat, it means that they have multiple outputs. And I'm not going to try to trick you and put the same output for two of the x that are the same. So this one, the 2, there's 2 of them. There's x equals 2 for -3, an output of -3, and x equals 2 for an output of +5. That is not a function. The x values repeat here. So no, and then our explanation would be that x equals 2 has outputs of -3 and 5. Now here, on the next question, the y values repeat. The 4 and the 4, but that does not matter. Multiple x values can have the same y values. Y values can repeat. X values cannot repeat with different y values. All right, so this one is yes. All right, this one represents something similar to a parabola, up and down, and this one represents something similar to a sideways parabola, which is why this one is and this one is not as well. So now when we're looking at the visual representation, we should be doing the vertical line test. We should be saying, well, does a vertical line cross through this graph at 2 coordinates on any points on the graph? And you can see here it does not. So if I take a pencil here and just run it along the graph, you won't be able to cross 2 coordinates at the same time, or you won't be able to cross the parabola twice. So this one is, but the number 10 is not. And number 10, we can have the same explanation as number 7. We could say that 2 has outputs of 1.5 and -1.5, or that 4 has outputs of 2 and -2. So we could have the same type of explanation here. X equals 4 has outputs of 2 and -2. That is why that one is not a function. Again, in math, we try to prove things wrong. We don't try to prove things correct. So that's why I'm giving the reason why these ones are false, and I'm not giving the reason why these ones are true. All right. Next one, question 11 and 12. State the domain and range intervals of increasing, intervals of decreasing, symmetry, and asymptotes for the following functions, and state whether they're even or odd. All right, so domain and range. What we're looking for is, does the arrows point up and down for the range? Let's do domain first. Left and right for domain. So this arrow points left, this arrow points right. This has a full domain. So we can do the double R, or we can do the interval notation, negative infinity, comma infinity. For the range, we're looking for, do the arrows point up as well as down? Does one arrow point up and one arrow point down? Well, this arrow points up and this arrow points up. It only points up. That means it has an infinite range pointing up, but coming down it has a minimum, an absolute minimum. Because both of the arrows point up, it has an absolute minimum, and that minimum is at y equals 0. It does not cross the x-axis in this case. It comes down to the x-axis, touches it, does not cross it. It includes 0 because it comes down and touches the x-axis. All right, now even and odd again is a point with the arrows. So if they both point the same direction, you have an even function. If they point opposite directions, you have an odd. So this is even because they both point the same direction. They both point up, the arrows. And asymptotes, well, that's going to be with the line that it doesn't cross. It does not cross x equals 0. I mean, y equals 0. Does not cross the x-axis. You could just put the x-axis as well. And then intervals of decreasing and increasing. So we read it from left to right. So from left to right, it's decreasing as it comes from negative infinity to 0. Decreasing from negative infinity to 0. And then increasing as it comes from 0 on up. And it does have symmetry. It can fold across the y-axis. Y-axis symmetry. That is a lot of stuff to put in one question. So I'm thinking about this question right now. After I've gone through everything here, that is a lot to put into one question. So what I'm going to do for my classes, and the other teachers can decide what they're going to do. I'm not going to do any of this. I'm going to have domain, range, symmetry, even and odd. And I will arrange the question on the test and the practice quiz when I print it off for you guys to say just that. So it'll only say domain, range. It won't say this. It'll say symmetry. And I'm not going to ask you asymptotes either. Domain, range, symmetry, even or odd. That makes it a lot easier. Oh, what you can also do for even or odd is, you see I gave you the power here. Just tell me if it's even or odd, the power, the lead coefficient power. All right, next one. Domain. This points left, this points right. And I know it points up and down, but it points left as well. Down to the left, up to the right. So this is another one where it's full domain. You could also write that as negative infinity. The range here is full range because this arrow points down, this arrow points up. Again, I can write negative infinity, positive infinity. This one's odd. X cubed is odd. And the symmetry here, it can't fold straight down over x. It can't fold straight across over y. Excuse me. But it can fold across the origin. It does have origin symmetry. So for origin symmetry, again, what you look at is, when you plug in negative y and negative x, does it keep it the same? So this does have origin symmetry. All right, next one. You're looking at the lead power. That's even. Now here I started it off with an x cubed, but the x to the fifth is actually the largest one. So be careful here. You're looking at the largest power, not just the first one. If it's out of order, it might be out of order. And for it to be neither, if the exponents don't match up, if they don't have the same even and oddness, then it would be neither. All right. Moving along. Evaluating functions. So -3 here is going to go into the x squared because that's where we use -3 because it's from -3 to 2, including -3 but not including 2. So f of -3 will be the quantity of -3 squared, +9. Remember, these go in as quantities. Before, we're going to use the bottom function, but there's nothing to plug in. There's no x there. So I just say f of 4 is equal to -3. Finished. Nothing to do. All right, write the line, the equation of the line passing through 5, -2, and 3, 1 in slope-intercept form, and then graph the line. Well, you can graph the line right from the start. 5, -2, 1, 2, 3, 4, 5, 1, 2. There's the first point. 3, 1, 1, 2, 3, 1. There's the graph of the line. From this graph, if you do it nicely enough, you can get the y-intercept, or you can attempt to get the y-intercept at least, if it's an integer y-intercept. If it's not, then you're going to have to use the point slope form of a line to get the intercept. So my slope here is 1, 2, 3 over 2. Right 2 down 3, or down 3 right 2. Down 3 right 2. And then this one is the same way. 1, 2, 3, 1, 2. You can see here it's not going to cross at a nice point perhaps. 2, 3, 1, 2. It looks like it might cross at 6. So a good guess for the y-intercept would be 6 if you don't know how to do the point slope form of a line. But there's the graph, which is half the points here. And then again, to get the y-intercept, you might have to use the point slope form of a line. Y minus the y value equals the slope, which is -3/2, times the quantity x minus the x value. And you can see here that slope is fractional this time. Excuse me, the slope is fractional, and so is the y-intercept. So we do have a fractional y-intercept. Y minus 1, -3/2 x plus 9/2. Adding 1 to 9/2 is going to give me my y-intercept. -3/2 x plus, that's 4.5, so it's going to become 5.5. 5 and 1/2. So it's not quite 6, the y-intercept, it's 5.5, if I was to graph it exactly. So again, I would start off by plotting the points, get the line from the plotted points, and then for the y-intercept, you can either take a guess, which will get you most of the points, or you can actually calculate it out with the equation, point slope form, to get the actual answer. All right. Next two. Write the slope-intercept form of the equation of the line described. Parallel. Parallel means same slope. So there's only one of these that have the same slope. I really don't have to go through the whole work here to figure out what answer the question is here. A is the only one with the same slope. It's got to have the same slope. Same. Yeah, same slope. So that's got to be A. Now, if I want to do it properly, if I want to actually do the question the way it should be done, I should do point slope form. Y minus y1 equals m. My slope is the same. X minus x1. So x minus 1 there. And then I can distribute the 6. Y minus 1 equals 6x minus 6. Take 1 and add it to -6. We get -5. All right, perpendicular means negative reciprocal slope. So perpendicular is the negative reciprocal slope. So there's only one of these that has the negative reciprocal slope. That slope is 1. When it negates and reciprocates, it becomes -1. Well, this is the only one that has it. And it does say point slope form too. So it'd be easy to do this. You do what? Y minus 0 is equal to -1 times the quantity x minus 2. Anyways, so same slope for the parallel, negative reciprocal slope for perpendicular. On my quiz, I'm going to shorten. I'm going to make it so it's only front and back, so it's easier to grade. But it's going to still have the same 18 questions, all right, guys? So don't be confused when I pass out my quiz and my practice quiz when it only has just front and back. Anyways, good luck.